So yeah, this talk, in about 30 minutes, I'm going to take you to a complete DevOps pipeline. Some disclaimer here. I'm from Microsoft. I'm a technical evangelist. Okay. Okay. Stab in the back. So, fair warning, there's going to be some product placement. Okay. So, looking at DevOps. So there's a lot of definitions about DevOps. But when we look at DevOps, it's basically about the union of people, processes, and products to bring value. That's what we want to achieve, right? We just want to deliver something to a customer or to a user, regardless of the type of application it is. Another disclaimer, given I've only got 30 minutes and not like 4 days, we're going to focus on the product. Yeah, it's going to be quite simple. So we're going to look at how can you set a practical DevOps pipeline. So how can we make it nice and easy to get an AngularJS application and get it really live in an environment and go to the full DevOps pipeline. So going a bit further, so DevOps, it's basically trying to match the developer side. Who's the developer here? Okay, oh, impressive. Is there any lost production operations guys here? Okay. So it's about making friends with the guys who didn't come to this conference. It basically deals with, we go through 4 phases in general when we try to deliver something, and we have an iterative process. So we start with planning and tracking the work we want to do. So if you're building something, it's good to plan beforehand, knowing what you're going to build. Once you know what you're going to build, well, you're actually going to build it. You're going to develop it. Hopefully, you're going to test it and not just throw it over the wall. And then we want to release it to some environment. Could be test environment, could be dev environment, could be production environment. And then, given our iterative nature, what we want to do is we want to learn, we want to monitor in that given environment, and we want to learn from that. If things don't work well, at least we want to know, and we want to try to act on it. We want to improve things. And that's where the cycle starts again. So this is what we try to achieve with DevOps. Not just coding something, throwing it over the wall, and hoping things work. Yeah. Now, more concrete then, what I'm going to take you through is we've got our developer machine sitting there on the bottom left-hand side, where we do all kinds of stuff. So we build stuff, we develop stuff, hopefully do some unit testing, maybe get some code coverage, and then we push it into some source code repository. Yeah. As a result of that, we're going to put in place some continuous integration. So we want to build our assets, our application, and then push it through, given our continuous deployment process, push it through some environment. Do some additional testing, load testing, stress testing, functional testing, all kinds of testing, which you typically don't do as a developer. And then we run the application and try to learn from it by adding some telemetry, adding some monitoring to our application. Okay. So it's a whole bunch of things that we need to do, all in 30 minutes. Yeah. So it's like, as I put on the first slide, it's like herding cats. It's not an easy task. To make things simple, I'm going to use the amazing tutorial from AngularJS. It's the superheroes, the Tour of Heroes application, just to make things simple. It's just a subset of it, but as we go through the different iterations, this application will evolve, and let's say in ngconf 2017, we'll have a fully working application. So looking at the initial step, so what are we going to do? We're going to plan our work. So first we need to do some who's Scrum or Agile users? Okay, yeah. So some of the concepts will come clear. So what we try to achieve in planning our work in an Agile way is trying to avoid a situation where you got developers saying, it's almost done. You know this feeling? So we've got a bunch of work to do, and there's a lot of things that have almost completed. And usually that situation happens kind of in the last day of the sprint, where things all of a sudden move to the almost done kind of side of the board. And that's what we want to try to avoid by giving some transparency. So one way we could do this, and what you're seeing here is, so disclaimer, product placement, Visual Studio Team Systems. It's a web-based tool that allows you kind of to manage your DevOps cycle. And this is kind of the initial dashboards that I've kind of created for this specific AngularJS application. So what we see here, let me zoom in still a bit. So what we see up the top hand side here is our DevOps team, and see what is the current state of our sprint. So we're 6 days remaining in our sprint. It's a 2-week sprint. We got 4 more days left, 6 days left. We got a couple of items have been completed, some in progress, and some have not been started yet. We can see some work that has been assigned to me. So I got my full dashboard on things that are happening. I can see my builds, my unit tests. I can see here my burn down chart. How are we doing? Are we on track or not? Okay, so that's kind of gives us a feel of how to manage our work. And then we can dive a little bit further and actually see if the Wi-Fi permits, actually see our Kanban board and see the current state of items, where we can actually say, well, as a result of this session here, this item here has been moved to done. This person has been started working here and is moving forward. And we can see our burn down charts evolve gradually. So we got this pane that will help you do your daily scrum, as to speak. Okay, so that's kind of planning stuff, nothing to do with AngularJS. So we'll look further how we can start actually the development phase. Switching back to some slides here. Now, we know what we need to build, so we're going to write some code, of course. First step, do some unit. Who does unit testing? Who does not do unit testing? Kind of shaming yourself now. So we do some unit testing, and what we'll do in this demo here as well is, well, it's good to do unit testing. I've seen situations where people say, yes, I do unit testing. There's one unit test. Yes, they do unit testing. So we can look at code coverage. What percentage of our code are we covering with our unit tests? Are we covering all the different scenarios? You can have 1 million unit tests and still cover a small percentage of your code. So try not to be fooled just by the fact of having unit tests. We're adding some version control, and then we're going to add some build solution. So why would we add like a build phase there? We can compile on our machines. We all have hefty developer machines which are perfectly capable of compiling stuff. It's basically to avoid this situation. Who has come across this situation? Okay. Were you the one that had the machine that was working? Okay. Again, something we want to try to avoid. Yeah. So how are we going to do this? So let's look at some code here. I'm switching to Visual Studio Code. Is this readable, or you prefer the white theme? Nope. So here we have the Tour of Heroes application. I've kind of collapsed some of the stuff. It's pretty basic. But yeah, you know how this works. If you go through the tutorials of AngularJS, you come across this sample. And if you kind of go through the quick start, you also get some unit testing. So what we want to do with our unit testing is basically, in this specific case, by default, you actually get Jasmine unit tests. So we're going to write some test cases. So here, for example, we're going to specify if our component has been defined. Is our title on our screen the one that we expect? Or another one, are we actually displaying, are we actually displaying 10 heroes? Because we are expecting 10 heroes. So in this specific case, we're just writing up some unit tests. You can see they're not complex. Just add them to your code. And you can add more as you evolve. This will add to the reliability of your code. We're going to add them, some Jasmine unit tests. Now, how are we going to run this? Well, on our machine, so we're on our developer machine now, we want to run these unit tests locally, compile our, do our transpiling of TypeScript, run our unit tests, and also get our code coverage. So what we do here, I've configured my package.json to do basically our test here, or test one. As you can see here, we're going to use Karma. Who is using Karma? Okay, quite a lot of you. So Karma is actually a test runner. And the nice thing with Karma is that you can just plug in your test frameworks. Do you want to use Jasmine? Do you want to use Mocha? You can just swap it in, just configure it, and it will use it. You can plug in reporters for your unit test results. Like if you want to have JUnit results, or you want to have your code coverage being part of that run, well, you can just configure it through Karma. Yeah, and this is what happens here in our karma.config file. So here you could see the test framework that we're going to use. So here it's Jasmine. Phantom.js is being used as a browser. So why am I doing this? If you run your tests on a build server, you may not necessarily have Chrome or another browser installed on that build server. Phantom.js is kind of a headless browser, allowing you to run through your like visual unit tests without the need for having to install Chrome or another browser on your build server, which you may not necessarily want. And then you see our reporters here. So the important ones that I need here for my build, and we'll see why we have them here, is I want to have JUnit as my test result format. So when I run my unit tests, I want them to be generated in JUnit format. And the one that comes after, coverage, is going to use Istanbul to do my code coverage of my JavaScript. If you want, if you look at our source code here is written in TypeScript, which is transpiled into JavaScript. If we do code coverage on the JavaScript, you may come across situations where actually you get no coverage for code that you have not written, because it was generated like this. So the JavaScript that was transpiled gets more code that you can't explicitly unit test. So for that, you may opt to also put in remap Istanbul to do kind of real TypeScript code coverage, if you want to. Something that I've done here, if you look at my package.json, I have added a coverage item here, where basically I'm using the remap Istanbul package to kind of take the output of the coverage and then generate, do a remapping into TypeScript. So then we get the real code coverage for the source TypeScript stuff. Now all this is nice. What does it look like? If I just open up the terminal here, and I can do an npm run test once, just to show you what the outcome of this is. So this is all running on my developer machine. No central continuous integration yet. Okay, we're starting Karma, which is launching our Phantom.js browser and is running through our three unit tests, which, lo and behold, are all successful. This is not rigged. This is intentional. So we got everything up and running. We're safe on our machine. It works on our developer machine. Now, how can we take it one step further and make this continuous integration? So we got our code linked to a Git repo. Your Git repo could be what you see here. Could be VSTS, so team services, but could be just as well be any Git, could be GitHub, could be Bitbucket, could be an external source code repo. Yeah, so we don't actually care. So we got our code sitting there, and we're going to set up a continuous integration build now. Yeah, so all of our development is done. Now we want a reliable build system that takes into account our unit test, that takes into account our code coverage for AngularJS, because that's what we want. So I can switch now to my build definitions. You can see here as a good, you can see them on TV, those TV chefs. They bake a cake, and they got one in the oven already. So this is my cake coming out of the oven. It's there already, just showing you how you would cook this cake. I'm going to create a new definition. So we just create a new build definition. And a build definition is going to describe basically every single activity that you want to have as part of your build. So there's a bunch of templates here. You could include Jenkins or Gradle if you have mobile apps whatsoever. We're going to live somewhat on the edge, pun intended, and choose an empty one. Now, the key thing is to make this a continuous integration build. It's kind of this one. It's quite obvious, continuous integration. So I'm just going to check this one. You could see you can pull in a different source code repo. Click on Create. It's going to fire up a new build definition. And now we can start adding build steps. So build steps are those activities that you need to do your build. Now, for our specific case, what we're going to do is, well, building our AngularJS application. Well, we already have NPM, and we have those NPM scripts in there in our package.json. So what we're going to do is we're going to take our package here. We can add an NPM command to do an NPM install because we want our dependencies as well. We want to run our tests, so we're going to add another one. You can see them appearing here to do our tests. So we'll run our test suite and our code coverage will be generated. And then what we're going to do is we're going to publish our test results so that the build system can pick up the results. And for this, we're going to publish our test results, close, and there we go. So now we can configure each of these activities. So the first one, there's not much configuration to happen. So we got our npm install. We can leave it as is. But we want it always to be run. And then the second one is going to be running our unit tests and getting our code coverage. So you saw it in the integrated terminal in VS Code. You actually saw me doing a npm run, and then we're going to run which command is going to be the test once command, which will do all of the magic, invoke karma, invoke phantom, etc., to do all of the fancy things that we need. Now, one particular thing we're going to do is we're going to continue on error. Why do we want this? To get a report regardless if tests fail, we still want to get all of the results and we want to continue maybe our build. Okay. And then finally what we're going to do, we're going to publish our results in my karma script I'm generating the results, so the JUnit results, which you can see here. Why have I chosen for JUnit? Because that is one of the options that I have here for picking my unit test results. I could have used NUnit VS Test or XUnit as well, depending on your framework of choice. And we're putting those in the results folder. This is where we generate our unit tests. Just in case you were wondering why is that folder, I'm switching back here to my karma.config file. You can see here that my output directory for JUnit is the results folder. Right. So just going to pick up those results and kind of store them internally so it can be used afterwards and it can be integrated in our build report. Okay. So we can add some more steps. This is where I become the TV chef and go back to my build definitions. I'm going to show you the full script. So we got our builds. Let me edit this one. So what you'll see is a few more steps which are in there. So we're doing our npm install, we're running our unit tests, publishing our test results, publishing our code coverage results. You see some more copying. So what is this copy going to do? It's basically copying to kind of an output folder so that it afterwards, so once we've compiled with unit tests, we've code coveraged everything, well, we need to deploy it somewhere. This is going to prepare kind of a deployment package. So we're copying, installing just the production npm packages, zipping the whole thing up, and then publishing it on could be a build server, kind of a file share. Yeah. So we got all of the steps here. Now, this is our continuous integration build. So just to kind of demonstrate that it works, it's not just slideware. What we're going to do is we're just going to quickly update this version number here, which is output in the title of the application. And we're going to commit it update version info. We're going to commit this one, and as it's committed, we're going to push it into our repo. So push. There we go. We've pushed it, and now we should see in our builds. Let's see. We got one in progress. So if you were wondering, all of this fancy, where is this build happening? So there's, and here you'll see the console of things that are actually happening on the build server. So we have what we call hosted build agents. So with VSTS, you get kind of this already pre-configured machines that build your solutions. Well, they are pre-configured. They are Windows machines. If you say, well, I have a dependency on Linux, or I have third-party components that are not available on that build server, you can spin up your own build agent on another platform. For example, if you're building iOS applications, mobile applications, well, you need a Mac. Well, you can spin up an agent on a Mac machine. In this specific case, this is running on a Linux box. So I have a Linux virtual machine, which acts as my build agent here, for no particular reason than to show off to you. So there's no specific need for Linux, but just wanted to add it. So we got our build. It's going through all of the steps. It's publishing, and we can see here, if you look at the summary of our build, that our build has finished. We got a bunch of artifacts, so our code coverage. We got our deployment package, which was generated. And looking at the summary, we can see that we have 3 tests that were executed successfully. And we should also see here our code coverage results being reported. So thanks to the components and the things we set in our Karma file. So now we got our continuous integration. It's building. We got our artifacts, so our binaries are sitting there. We got our results reported here, which is nice. So at least it compiles on some other machine. But now we need to release it somewhere. So it needs to deploy all of these artifacts. So not to only have it on our work machine, on our developer machine. So it could be sent to a test environment, some staging environment, some stress testing environment, some whatever environment you want to do some validations and verifications of the application in some form or another. And so for that, well, you may say, we're agile, and we do CI and CD all in one step. This can be done. In the build activities that you saw there, there are also deployment activities. Now, this is cool if you want to live on the edge, but not intended this time. But sometimes you need some more either validation, that somebody needs to go give approval for putting somebody on some application version in a live environment. Maybe you don't just want on every commit have a new version landing in the live production environment. So maybe you want some approvals in there. Maybe you want to have like a pre-validation step by going through first the staging environment, run some load tests, and only then, when everything passes successfully, put it into production. So for that, we have kind of functionality which is called release management. That kind of allows you to set up this environment, to set up these steps. I'm going to switch here to the releases part here. So in here, you can actually see, and you saw this in my dashboard here. If I have my dashboard here. You actually get the overview of what versions landed in which environment. So we have our view here on our builds and unit tests, but here in our release definition, we could see that right now, in our staging environment, we have release 10, and the same version is landing in production. Here you can see a history of previous versions. Some have been rejected because of quality issues, for example. Yeah. So we got 2 environments. So how we specify this kind of model, this chain, this flow of releasing something in production coming out of our continuous integration. So we can create what we call a release definition. So in that release definition, very similar to what we had with our build definitions is we're going to specify, zooming in a bit, our environments that we want. And for each environment, we're going to kind of list the different tasks that need to happen to deploy something in an environment. Another disclaimer, product placement for Azure. This could be another environment as well. There's a bunch of deployment activities to deploy it elsewhere. In this specific case, in staging, what I'm going to do, I'm going to deploy to Azure, potentially run some performance testing, and then add some release annotations for my telemetry system. In production, I'm just going to deploy and just annotate my, my telemetry. Now, how do I define when I can deploy? Is this continuous deployment? Is this manual deployment? Because the options are possible. This is done through what we call triggers. So we can specify triggers. And again, it's kind of straightforward. How do I make a continuous deployment? Well, there's a checkbox for that. So we can set a checkbox as soon as we get something coming out of our continuous integration build. So here are build and unit tests, continuous integration artifacts. As soon as something is ready, well, do a new deployment. So there's source control behind this as well. So we got our trigger defined. So we have our continuous deployment. Now, how do we differentiate between kind of approval workflows, or do we have automatic actual deployment here? Well, we can specify for each environment who needs to approve. We could see here for staging, we do automatic approval, so actually no approval. For production, on the other hand, what we'll ask for is, show me my approvals. We got one approval needed to be able to deploy to production. You can make it also conditional. If it deploys in staging, then deploy to production. Okay. Now, we've configured this one to be continuous. So if I now make another small code change, and let's say we have 1.4, and commit that one, update version again. Typing. What we should now see is that we have a continuous integration build kicking off, followed by a release deployment into staging, and then we'll have an approval for production. Okay, we're pushing that one. So, and while that one is happening, we'll see our build. Let me switch back to our builds. We should have one that is now queued. So one is in progress here. As a consequence, we'll see something landing in the results. Kind of to show you what are the results of such a load test, for example. Let me show you this one here. This would be kind of something results that you get out of a load test of our Tour of Heroes deployment with some graphs, which are fancy, again, to show off that my application is quite performant. Not arguing whether it's React.js or AngularJS. Okay, so that one is running now in the background. We're not going to wait for this one. So once we've released, we're ready. Our application is running in production. I'm going to come back in just a few seconds to show you the actual version running in that specific environment. The next step would be to kind of monitor and learn from the environment. Yeah. For that, we can add some telemetry, and there are solutions for adding telemetry. There's New Relic, there's Azure App Insights. There's multiple ways that you can do it to inject some telemetry data that you can then use to learn from. One sample dashboard that you could get if you're using kind of, let me zoom in a bit. Here with application insights, you could get these kind of maps, application maps, where you can see what is my availability. So I'm 100% available. I have some client-side scripting errors. It's doing 20 AJAX calls, of which only 4.2% are failing. So I'm quite okay in terms of quality. Not a lot of things that we need to do. We can get some view on what browsers are being used. And it seems that Chrome just has the edge over Edge. Oh boy. Am I doing too many Edge jokes? This is... I'm on the edge. Okay, great one. It's subliminal, you know. So you can generate all these kinds of reports. And one of the things I wanted to show you here is if you look at some of the details, and this is going to be pretty much towards the end of my session here, is that in this graph where I can see kind of the client-side performance, what is happening in the clients. I have some send happening, responses being received. I have some client processing, so you can see all this on the graph. You can see these indicators here at the top. And those are actually those release annotations that we set in our release management, so that we can see if we get a spike. So for example, this one here is kind of a spike in performance, in client-side performance. Well, it was due to a new release of the application being deployed. So we had a new release there, which resulted in the initial request being slower. So we get a correlation between our telemetry and our release system, which is kind of useful, because sometimes you're wondering what happened, and maybe some release was deployed automatically because of some changes in the application. Okay. And I'm quickly going to check if our release has been completed. Let's see. So our release 11, we can see that it's still in progress in our environment. Well, due to time, I'm going to let it running. You can come after my session and see the results of my Tour of Heroes application deployment. So what we've seen in this session, a bunch of tools being integrated. There's a lot of tools that I've used here. You could use other ones, but I wanted to show you kind of what are kind of the different pieces that you need in doing DevOps. It's not just coding, throwing over the wall, and hoping for the best. Try to put something in place that allows you to get kind of a reliable release management system. Okay. A few more links. And for your information, whatever you've seen here is for free. So enjoy.